So now we have learned some functions. When we take the limit, we just need to plug in the numbers to get the result, which is your limit, right? And for this kind of function, is a very, as I said before, which is called a very nice enough function. You can just find the limit, just plug in the numbers to get your limit, right? And we give this kind of function a name, which is called a continuous function. So this is the definition. A function f of x is said to be continuous at the point x equals c if the limit as x approaches c is equal to just plug in the numbers c, okay, which is equal to f of c. Then we say this function is continuous at x equals c. So if we say a function is continuous on an open interval ab, that means it's continuous at each point in this open interval. So in other words, at each point, the limit is just the f values at this point. Okay, so now let's look at some remarks for this definition. First one, roughly speaking, what is the continuous function? If you draw the graph of a continuous function, you can draw the graph without lifting your pen. So this is a continuous function, right? If you draw the graph continuously. So that means there is no holes, no breaks, right? So if you have a hole here, you have to lift your pen, you can see, right? If you have some breaks here, you have to lift your pen to here and then draw down. All right. So this is not continuous function. This is continuous function. Okay, so this is the, roughly speaking, what's the meaning for the continuous function? No holes, the graph of the function has no holes, no breaks. So now let's look at another one, which is called a one-sided continuity. It's just some extension for the continuity. So we say f of x is left continuous at x equals c if the left side limit is equal to f of c. We say a function f of x is right continuous at x equals c if the right side limit is equal to f of c. So in the previous example, so let's look back to this example. Okay, this example. Let's look at the right side limit. So let's look at f of 4 here. What is f of 4? f4 is equal to this solid point, it's equal to 3. So you can see this x approaches 4 minus 4 plus of f of x, which is equal to 3. So this function is right side, right continuous, is right continuous. Okay, right continuous. But when the limit x approaches 4 minus, which is equal to 1, which is not equal to f of 4, f of 4 equals 3. So this one is not left continuous. Okay? And for the, of course, this is the left continuous, right continuous at x equals 4. Right? At x equals 2, it is neither left continuous nor the right continuous, right? Because it's not equal to 4, right? The one side limit. They are equal to 3, not equal to 4. F of 2 equals 4. Okay. So we talked about the continuity. So now some student may ask, what are the situation for the discontinuity? So this is the remark 3, discontinuity. So we have several discontinuous points. So the first one, which is this one. We have a circle here, then we continue. At this point, it takes value, for example, here, maybe here, maybe here. It doesn't matter. Okay. And for this kind of, this is discontinuous. It's discontinuous at this point, right? Because when you draw the graph, you have to lift your pen to draw the point here, then continue this curve, right? You need to lift your pen to finish this graph. So this is discontinuous at this point. But this discontinuous is very, very special if you fill in the point here. You will make it to be continuous, right? We can draw the graph continuously. So this kind of discontinuity is called removable discontinuity. So that means you can make it to be continuous by just fill in the point. For this kind of things, right? This curve, even you fill in this point, you cannot make it to be continuous. You have to lift your pen to continue to other branch, right? You cannot connecting these two points by adding a point. So this kind of discontinuity is called the jump discontinuity. Another one is, for example, is this one. So you see, this is the vertical asymptote, right? This is a vertical asymptote. When on the left side, it will approach this vertical asymptote forever, right? So this kind of discontinuity is called infinite discontinuity. For both cases, jump discontinuity and infinite discontinuity, you cannot just fill in some point to make it to be you cannot make it to be continuous. So this kind of, compared to the first one, you can make this discontinuous function to be a continuous function just by redefine the values at this hollow circle, right? But for these two, you have no idea, so which is given name, which is called non-removable discontinuity.